Hi, everyone. It's my pleasure to introduce our work, a wideband high-efficiency side-connected magnetoelectric dipole antenna array using novel feeding technology for W-band. With the development of wireless systems in W-band such as radar, remote sensing, and imaging systems, high-gain, low-cost, and wideband antenna arrays are increasingly attracting attention as the key component. As for some space-limited and long-range high-resolution required detection systems, planar antenna arrays with wideband, low profile, low cost, high efficiency, low loss, and compact feeding network are deeply required and widely studied for W-band in this decade. The proposed antenna array structure has 4 layers. The top layer is the proposed side-connected ME dipole radiating elements based on PCB process. The second and third layers are the machined feeding structures for 2x2 subarrays based on the bar-loaded cavity and coupling slots. The bottom layer is the machined ridge gap waveguide feeding network with proposed U-shaped T-junctions. Thus, a wideband, low-cost, and high-efficiency antenna array combining novel feeding structure with side-connected ME dipoles for W-band around 100 GHz is proposed. As we can tell from the structure and design process of the proposed ME dipole element, the proposed ME dipole has side connections at both sides of the radiating slot, forming a dumbbell-shaped slot in the middle of the patch, and the relative bandwidth is significantly improved from 17.8% to 31.8% by the side connections. The main part of the proposed feeding structure for the 2x2 subarray is a metal bar-loaded cavity made with pin-typed EBG structures. And the metal bar effectively improves the matching performance of the subarray according to the simulation results. And the subarray achieves high performance with relative bandwidth of 30.7%, peak gain of 15 dB, and total efficiency over 90% due to the novel feeding structure and the proposed ME dipole. As to the feeding network, the proposed U-shaped T-junction have better low frequency, 80 to 90 GHz, matching performance with the same physical size compared to conventional T-junctions, achieving more compact structure and wider bandwidth for the feeding network. A prototype of the proposed 8x8 antenna array is simulated and measured to verify the performance. The measured bandwidth is from 81.5 to 108.6 GHz. The measured gain is from 22.3 to 26.6 dB, and the measured radiation efficiency is about 72% on average. The measured results have good agreements with the simulated results. The detailed comparisons are made between our work and previous works. Compared with previous 8x8 antenna arrays, this work has a higher aperture efficiency with small electrical size thanks to the compact feeding network with novel U-shaped T-junctions, making the distance between elements smaller. Moreover, our work has wider bandwidth and higher efficiency compared with previous W-band and higher band antenna arrays thanks to the low-loss feeding network and high-performance ME dipole elements. The fabrication cost of our work is also controlled by combining the PCB-based radiating part and gap waveguide feeding part. Thank you for your attention.